Welcome. I'm Bruce, and this video explains an oil field innovation that allows you to drill and complete 2 wells for the price of 1. Lower costs and the added value of additional production can significantly affect your company's return on investment and cash flow. Oil and gas wells are very expensive to drill and complete, but our company, Oilfield Innovations, has developed a method to get 2 wells for about the price of 1 using a simple tool for accessing multiple reservoirs through a single wellbore. Our tool can be installed in an existing well during a workover or installed during a completion of a new well. A wellbore is primarily a hole drilled into the ground, which has been protected by casings cemented into the hole and perforated adjacent to a reservoir that you want to produce from or inject into. This is an illustration of 2 perforated zones in 2 different reservoirs that can be used for commingled production or commingled injection. Sometimes conventional wells can produce from or inject into both reservoirs, but only if the reservoir pressures are about the same. The direction of flow for conventional commingled production from 2 reservoirs of equal pressure would look something like this. Alternatively, as illustrated here, the direction of flow for conventional commingled injection into 2 reservoirs is generally unbalanced because the pressure drop across the first set of perforations will consume most of the injected fluids. Differences in pressure are the most common reasons that production or injection from or into 2 different reservoirs through a single wellbore cannot conventionally occur at the same time. If the pressures in the 2 reservoirs are different, then production cannot conventionally be commingled without losing higher pressure production into the lower pressure reservoir. As shown, production from the higher pressure reservoir flows into the lower pressure reservoir, which can represent a significant loss of revenue and value, and hence is not conventionally practiced nor allowed by regulatory agencies. The real question is, what if you could produce 2 differently pressured reservoirs through the same wellbore without losing production? How much would that be worth to your company? If 2 or more reservoirs discovered by the same wellbore have different pressures, or there is a need to perform a drill stem test to determine if the pay packages are connected or separate, then production or injection from 2 different potential reservoirs cannot be commingled within a single flow stream at the same time. Conventionally, either 2 separate wellbores are required, or production can only come from one of the reservoirs at a time, whereby after killing the well, removing the completion and isolating the lower reservoir with cement or a bridge plug, the upper reservoir can be produced by recompleting the well. Regardless of whether you drill and complete 2 conventional wells, or if you wait, pay for workover later, and lose the net present value of accelerated production, both options are expensive. Alternatively, what if you want to produce from one reservoir and inject into the same reservoir or a different reservoir? Water and or cutting slurries can sometimes be disposed of by injecting down the annulus of conventional production well, but only above the production packer. Also, injection down a conventional annulus cannot always be easily controlled, and or the hydrostatic gradient can require significant pump pressure to dispose of the fluids or slurries downhole. Conventional water and steam floods need to inject water or steam below the producing reservoir to stimulate production, and because the annulus is blocked by a production packer, require 2 conventional wells, one for production and another for injection. Fortunately, if you want 2 wells for the price of 1, or the added value of accelerated production from 2 differently pressured reservoirs through a single well, Oilfield Innovations can help. Our multi-production injection crossover allows you to produce from 2 differently pressured reservoirs through the same well, or, alternatively, produce from one reservoir and inject into the same or a different one below the producing zone through a single well. Oilfield Innovations can help improve your return on investment and the net present value of your project by accelerating production from 2 differently pressured reservoirs through a single well. Alternatively, if you want to produce and inject, for example, water, steam, huff and puff chemicals, or simply dispose of produced water into a subhydrostatic pressured reservoir, Oilfield Innovations can help cut your well costs in half by reducing your well count. Oilfield Innovation's Multi-Production Injection Crossover, or MPIX tool, can be run into the well like any other completion string, whereby it uses a conventional production packer at the bottom, a conventional liner hanger and packer functioning as a completion hanger and packer attached to the middle of the tool, with customer-specified functional completion jewelry like subsurface safety valves, sliding sleeves, nipples, plugs, and prongs also included. While the previous string pictures two subsurface safety valves, one for each of two production streams, they are optionally specified by the customer. For example, sub-hydrostatic wells using rod pumps don't need and can't use subsurface safety valves, so they would not be included. Whether or not you want a subsurface safety valve is up to you. Our tool doesn't need them. We showed the subsurface safety valve in this example to illustrate how versatile our MPIX tool is when selectively controlling flow streams in, for example, a naturally eruptive well. A conventional completion is run by picking up the tailpipe and then the production packer. With our MPIX tool, the procedure is the same. You just pick up the completion hanger packer and MPIX tool after running the production packer and before running the tubing hanger and/or the optional subsurface safety valve. Let's zoom in on the completion jewelry after it's been installed in the wellbore to see an example of how our MPIX tool can be used within a subterranean wellbore. A completion string or drill stem test string is run into the hole like a conventional completion. The packer at the lower end of the completion string is set to isolate the lower reservoir from the upper reservoir for isolated production from the lower reservoir through the lower tubing string. The completion hanger packer isolates the upper reservoir from the lower reservoir to allow isolated production of the upper reservoir through the annulus between the lower and upper packers. In this example, we show a Baker DB production packer set in 5.5-inch casing with an optional subsurface safety valve just above it for illustration purposes. Generally, as previously shown, tubing would be adjacent to the upper reservoir's perforations and not a subsurface safety valve. As shown here, production from the upper reservoir would flow in the annulus outside the subsurface safety valve, while production from the lower reservoir would flow through the inside of the tubing and can be controlled separately by, for example, closing the subsurface safety valve to shut off fluids flowing through the inside of the tubing. Now that you understand our MPIX tool can be used in a smart completion mode to control or stop production from one reservoir while allowing flow from another, let's look at its lower end. The lower end of Oilfield Innovation's Multi-Production Injection Crossover, or MPIX tool, comprises a cap with internal V packing seals that isolate a chamber for customer-specified completion jewelry, like a sliding sleeve to replace a subsurface safety valve, or, for example, temperature gauges, chemical injection subs, or other equipment associated with production from below the packer within the tubing. Production from the upper reservoir perforations flows up the annulus, above the production packer, between Oilfield Innovation's MPIX tool and the casing. The MPIX tool's chamber can use flush joint connections, or, for example, as shown here, new VAM connections, where the coupling connections extend beyond the diameter of the chamber's walls. While the clearance between the couplings and the casing may appear small, new VAM connections are special clearance connections, and the flow area between the 4-inch new VAM coupling and the 5.5-inch casing is as large as the flow capacity of the external upset 2 3/8 tubing inside the tool. The MPIX tool's lower chamber houses optional equipment specified by the customer and, therefore, needs to be accessible. To meet this need, the MPIX tool uses a smaller diameter housing that can pass through the internal diameter of the customer's completion hanger packer. The housing can then be attached to a larger diameter chamber capable of holding the customer-specified completion jewelry. In this example, we show a 3.5-inch lower MPIX tool housing attached to a 4-inch new VAM lower chamber, using a swedge with a 3.5-inch new VAM coupling and pup joint. Now let's look at the customer-supplied completion hanger packer that allows the MPIX tool to cross over flow from the annulus to the tubing and vice versa. In this example, we show a qualified Baker hanger packer, typically for uncemented scab liners, that we use in a reverse position to tension the tubing and isolate the 4.5-inch MPIX crossover inside a 5.5-inch casing. The hanger is used to tension the tubing while the packer is used to seal the annulus, with production from the upper perforations flowing between the hanger packer and the MPIX tool housing. Conventional uncemented scab liner hanger packers, like the proven Baker one shown here, can use a J-slot arrangement designed to facilitate running the hanger packer in an upside-down position to tension the tubing attached to its upper end. Our MPIX tool can use these field-proven hanger packers to allow the completion and the MPIX tool to be moved during, for example, a subsequent reperforation workover. Alternatively, the customer can specify a different one, like a permanent packer suitable for a high-pressure, high-temperature well. Oilfield Innovations likes to show our 2 3/8 by 5.5-inch MPIX tool because it can be used in a number of different ways. For example, you can use an MPIX tool within 5.5-inch tubing installed within 9 5/8 or 9 7/8-inch casing as shown here. Customers who want to simultaneously flow and or inject from or into 3 differently pressured reservoirs instead of just 2 can use multiple MPIX tools. Other customers may want to keep their production annulus for monitoring and still flow 2 differently pressured reservoirs through the 5.5-inch tubing using the MPIX tool. Alternatively, what if you only have 1 reservoir? The MPIX tool can be used to pre-install a velocity string to maximize production while minimizing later workover costs. You can flow a reservoir through both MPIX tool strings to achieve a high level of production, and then subsequently switch to the MPIX tool's internal velocity string when liquid loading becomes a problem. Without further ado, let's look at the heart of Oilfield Innovations' MPIX tool. Our MPIX tool crosses over flow from the tubing chamber below the hanger packer through the inner housing. It also crosses over flow from the lower annulus between the inner housing and the outer housing attached to the top of the hanger packer so as to flow through the upper tubing chamber. As you can see, the MPIX tool is a welded structure that can use any specified metal and can be pressure tested and qualified for your application. You decide what completion jewelry you want attached to the crossover above and below the hanger packer to meet your well's needs. The MPIX tool has no moving parts, comprises a metal arrangement that's easily tested and qualified, and can be used with proven completion technologies from any vendor. An important feature of our MPIX tool is that you do not lose access to the lower end of the well. As shown here, proven plug and prong technology can be used to block the internal diameter of the tubing to allow crossover between the annulus and tubing above and below the plug. Normal slickline intervention can be carried out by removing the plug and prong to access the lower end of the well. The upper and lower MPIX tool chambers can optionally use field-proven sliding sleeve technology to, for example, shut off crossflow before removing the plug and prong to access the lower end of the reservoir with wireline or slickline intervention. As shown here, slickline operations can be used to close the sliding sleeve before removing the plug and prong and reopen the sliding sleeve after the plug and prong has been reinstalled. Like the lower MPIX chamber, the upper chamber contains customer-specified completion jewelry associated with one of the flow streams and is sealed by V-packings or chevron seal arrangements. Similar to tubing exiting the lower MPIX chamber, the tubing exiting the upper chamber can also be controlled by a subsurface safety valve that can close production from the upper reservoir while allowing flow associated with the lower reservoir to continue. A subsurface safety valve can be opened or closed or may not be present. As we've mentioned, the choice of completion jewelry is yours. We have patented the crossover, and you are free to provide equipment from any vendor, and we will fit it to the MPIX tool. Now that you've seen the various aspects of our MPIX tool, we want to just summarize how it works. The MPIX tool can be used on a single reservoir if you want to pre-install a velocity string to increase the value of production, or it can use a conventional packer to isolate 2 differently pressured reservoirs. Our MPIX tool then crosses over flow to allow you to control each flow stream separately without losing wireline access to the lower end of the well. Flow to or from the upper reservoir flows within the annulus between the MPIX tool and then crosses over to flow within the tubing above the MPIX tool through a conventional tubing hanger. Flow to or from the lower reservoir flows within the tubing below the MPIX tool and then crosses over to flow in the annulus above the MPIX tool through an annular flow spool. Annular flow spools are common proven technology used during solution mining in the underground hydrocarbon storage industry. Accordingly, you can separate and control the flow to and or from two differently pressured reservoirs. Our MPIX tool uses a conventional uncemented scab liner hanger packer as a completion hanger packer to isolate upper and lower chambers that cross-connect the tubing and annuli across the hanger packer, together with a conventional plug and prong that can be removed to access the lower end of the well. The chambers used to cross over tubing and annuli above and below the completion hanger packer can also house customer-specified completion jewelry, like sliding sleeves to control cross-flow when, for example, removing the plug and prong to access the lower end of the well. Finally, our multi-production injection crossover tool, or MPIX tool, can be retrofitted into existing wells or can be matched to new well construction so as to maximize the flow areas associated with both the tubing and annular flow streams. That completes this video on how you can use and configure Oilfield Innovations multi-production injection crossover, or MPIX tool, to maximize production from your reservoirs while minimizing the cost of future workovers, or realize the net present value of accelerated production. Oilfield Innovations would like to thank you for the time you've taken to watch our video and invite you to look at our other new technologies. Thanks again and goodbye.